Electric charges. So we'll try to understand here what is electric charge. We know that when two like charges are kept, like two protons, okay, they are having charge. Now two like charges repel each other. Similarly, when two unlike charges are kept, suppose one proton and one neutron, then they attract each other. So unlike charges attract and like charges repel. So what is exactly a charge? An electron repels another electron at a distance of 1 centimeter, and experimentally it is found that this force is of magnitude 2.3 into 10 to the power minus 24 Newton. This property of electron responsible for electric force is called charge. So because of the charge, they attract or repel each other. As suppose if the particles are having mass, then there is a gravitational force. So because of the charges, we have the electric force. So as masses are responsible for gravitational force, charges are responsible for electric force. Unit of charge is coulomb. So the charge on a proton is 1.60218 into 10 to the power minus 19 coulomb. Now normally we depict the pictorial representation of electric charge is like this. So it is a positive charge, so the electric lines of force are coming out of it. Similarly, this is a negative charge, the electric lines of force are towards it. Now what are the properties of charge? Now we will see the two main important property of charge. One is charge is quantized, other is charge is conserved. Now what is quantization of charge? The charge on any object is always integral multiple of E. E is the charge of an electron. So this object can have one electronic charges, two electronic charges, three electronic charges, but not in between, like 1.3 electronic charges. This cannot have, and can be changed only in steps of E. E is the charge of electron. So therefore we say that charge is possible in fixed quota. So this is called quantization of charge, or we say charge is quantized. Other important property of charge is conservation. That is, we cannot create net charge. So the charge of an isolated system is conserved. It is possible to create or destroy charged particles, but it is not possible to create or destroy net charge. Now to understand this conservation of charge, let us take this following example. See the picture here represents the beta decay in an atomic nucleus. What happens in a radioactive atom? Alpha, beta, gamma particles comes out. Now here when the beta comes out, let us see what is the net charge. So in a beta decay process, the neutron converts itself into a proton and a fresh electron is created. So the charge however remains zero after the event. So before and after, the net charges remains the same. This is called the conservation of charge.